All right, hey, honors chemistry. So I got a question. Shout out to Talia, about walking through another example of this PVn&T calculations. So I'm looking at question number 4 from your worksheet. All right, so it says, what would be the new volume? All right, so it's looking for a volume already. What would be the new volume if 250 centimeters cubed of a gas at 25 degrees Celsius and 730 millimeters of pressure were changed to standard conditions of temperature and pressure? So let's try and get all the information out of here. So it says, what would be the new volume of this gas? So I know I need to find my new volume. If 250 centimeters cube of gas, so it's telling me that my gas is originally at 250 centimeters cubed. And remember, centimeters cubed is a volume. So I'm going to write that here. 250 centimeters cubed of gas at 25 degrees Celsius. So we know that degrees Celsius is a temperature. That's my initial temperature. And it's at 730 millimeters of pressure. So that's my initial pressure, 730 millimeters. And it's when we say 730 millimeters, we mean millimeters of mercury. It's kind of assumed here. And it was changed to standard conditions. Now, something I ask that you write on the beginning of this worksheet are that standard temperature and pressure, which we are going to call that STP, is 273 Kelvin and 1 atmosphere. Okay? Which STP can also be 0 degrees Celsius and 760 millimeters of mercury. I just converted my temperature back to Celsius and my pressure into millimeters of mercury. This means that if I tell you something's at standard temperature, it's at 0 degrees Celsius, which is the same thing as 273 Kelvin. If I tell you that something is at standard pressure, it's at 1 atmosphere, which is the same thing as 760 millimeters of mercury. All right, so it says I changed my temperature and pressure to 273 Kelvin and 1 atmosphere. Well, let's start with the pressure. Well, I was given my pressure in 730 millimeters of mercury. I either want to change it to atmospheres or I want to keep things in millimeters of mercury. Well, I already know that my standard pressure is 760 millimeters of mercury, which is the same as 1 atmosphere. So I'm going to write 760 here. That is my new pressure. It's because it's standard pressure. My standard pressure in millimeters of mercury is 760. And then it says my new temperature is 273 Kelvin or 0 degrees Celsius. I'm going to write 273 Kelvin because I know from things that we've discussed in class that I must convert degrees Celsius to Kelvin always. And I'm going to do that. To do that, you add 273. So 25 degrees Celsius plus 273 equals 298 Kelvin. So my temperature is really 298 Kelvin to start. Okay? And now I'm looking for a final volume. That's what it's asking. It says, what would be the new volume? And then it also tells me that N is constant. So I'm going to cross this out. All right, so I have organized my information, and if you missed it, I would replay the video. And now I have to see what's going on. Well, my pressure went up, and my temperature went down. Okay? Now this is difficult because I have two factors here. I have two factors, and so I'm kind of splitting this last box into two things. And so, if I split this into two, I'm thinking about how pressure is affecting my volume. So if my pressure goes up, pressure and volume are inversely proportional, that means my volume needs to go down. So if my pressure goes up, my volume must go down with respect to pressure. And then if my temperature goes down, that means that my volume must also go down. So volume with respect to temperature must go down, right? Now, this looks like it's a lot. In general, my volume is going to decrease. Sometimes I may have it that my pressure is making my volume increase, and then my temperature is making my volume decrease. That's going to be a combination of things. But for right now, this is going to help me with my factors. Okay? So I always start with what I want. And I want volume. So I'm going to start with 250 centimeters cubed of volume. Okay? And I'm going to end up with volume in the end. Let's do one factor at a time. All right? And then I'll show you how you could do it all together. Let's just say with respect to pressure. Pressure factor. All right? So remember my increasing and decreasing factors. If I want a decreasing factor, I do small number over big number. If I want an increasing factor, I want a big number over a small number. And I use my pressure or my values that are changing as my factor. All right, so my factors are my values that are changing. So let's just do pressure first. So I'm going to do the pressure factor that's happening to my volume. I need my volume to decrease because my pressure is increasing. Remember, pressure and volume are inversely proportional. So whatever happens to my pressure, the opposite must happen to my volume. So I need to write a decreasing factor by the pressure. So decreasing is small number over big. I have two factors here. I have two numbers that could go on my factor. I have 730 or 60. I'm going to do small over big. Okay, I'm doing one factor at a time. Okay? Now, if I do this math, all right, this is going to show me how my volume's changing with pressure. So I'm going to do 250. I'm going to do this in the calculator. So 250 times 730 divided by 760, and I get 240.13 centimeters cubed. But that's only by my pressure. Now I need to do another factor with this value, right? My volume is going to get smaller twice. So now I need to take this down, this 240.13 centimeters cubed, and I didn't even do sig figs. I'm going to show you how my temperature is going to affect this volume also. Right, so two things are happening to my balloon here, or two things are happening to my volume. My pressure is changing it, and now I need to also change it because of the temperature. All right, so we looked up here and we saw that my temperature is decreasing. Temperature and volume are directly proportional. So since my temperature goes down, my volume needs to go down, and I need to do another decreasing factor. Since my temperature is decreasing, my volume must also decrease, so I need to multiply by a decreasing factor. So I'm going to write decreasing factor by temperature. Okay, so I'm going to do, and this has to be in Kelvin. Remember that, only in Kelvin. So I got to do small over big. So 273 Kelvin over 298 Kelvin. If I do this math again, I'll do my 240.13 times 273 divided by 298. I get 219.9. I'm going to round that to 2 sig figs. I'm going to get 220 centimeters cubed. And that is my answer for question number 4. Now, if you didn't want to do it by two factors, you could combine all of these, right? And if you didn't want to do it in 2 steps, you could do it all in 1 step. So instead of doing the 2 steps that I showed you here, you could do 250 centimeters cubed times, I could do my pressure factor, which we know that my pressure is increasing, so I need a decreasing factor. So I'll do my 730 millimeters of mercury over 760 millimeters of mercury. And then I'll do my temperature factor. My temperature factor is also another decreasing factor. My temperature decreases, so my volume must decrease. So look at what I did here. Instead of me doing this in 2 steps, I do it all in 1 long step here, and I'm going to get the same answer. I'm going to get 220 centimeters cubed. Okay? Alrighty. So I'm hoping this video is another supplement and helpful with calculating increasing and decreasing factors and this PVn&T table. This will be the hardest type of where it includes more than one factor and maybe having to worry about our units and then significant figures. Let me know if you have any other questions or concerns about this type of question. I would just continuously ask you to rewatch or watch this video and maybe ask questions about this video. Very specific questions about where I did this and why I did that. Alrighty? Hopefully this has been helpful. Make sure you're reviewing this for our quiz that's coming up.